Good evening, everyone. Let's unmute and respond if you can hear me.
Good evening, ma'am.
Good evening, ma'am.
Okay. It's good to have you once again for ETH 320. Just some information before we start. Good evening, everyone. Some information. Let's unmute and respond if you can hear me.
Good evening, ma'am. Good evening, ma'am.
Okay.
Good evening, ma'am.
To have you once again for ETH 320. Okay, great. We'll be having our in-course next week. Has the class captain joined yet? Course rep, are you here? Or the assistant? None of them is around. We'll be having the in-course for my part next week. So do you know what you will do for me? I need a classroom. We'll be having our in-course next week, and we have to make arrangements for the classroom we use because it will be physical, it will not be online. Are we together? Please, I need us to respond.
Yes, ma'am.
Okay, so please get across to your course rep to give us a classroom for what time are you in school on Wednesday? Or what is the lecture time for this course on your timetable? On the timetable, what is the lecture period and venue? Does anybody know? Class, what's the normal lecture period for this course on the timetable? Nobody knows.
Ma, it's Monday, ma.
Time.
2 to 4 p.m.
So what's the venue?
Ma, the venue is saying DLI.
DLI. So are you okay for us to have our in-course for this course on Monday by 2?
No, ma'am.
Why no? Just my part, not Professor Samuel and I's part. Just my part.
Ma, we can have it on Friday.
Which Friday? No, it's between Monday and Wednesday. We can't have it on Friday. Is that Monday, Tuesday, or Wednesday? We need a free class. That's all we need. On time. Let's say 10 a.m.
Okay. Wednesday is fine too.
Ma, we have test on Wednesday, ma. We can do Monday.
Okay, Monday 10 a.m. You use one of the SOS. How many are we in our class?
Ma, we have about 120, 130.
120. Whoa. 120. That's a large class. So we have to look for a bigger venue. We cannot use any of the SO classes. What classroom in DLI? It's just DLI, no number, nothing.
Ma, they put DLI, ma.
Okay, so do you know what you do for me? You'll go and secure that venue against next week. Are you the assistant coach rep or are you just assisting them?
Ma, I'm just assisting them.
Okay, so please get across. So not the coach rep and his assistant, none of them is here yet. Please, I will need to secure that venue for 2 p.m. on Monday, our normal lecture period. So that we'll have a INCOS, DLIA. Wow. So that we'll have our INCOS on that day. You're a large class, so we need a big venue. Please tell the course rep to get across to me. Latest by tomorrow. We need to physically go and check the place to be sure that it can contain everybody. Have you ever had any class there? As in even if it's not this one, any physical class in Akoka. Have you had any physical class in Akoka?
Atoma.
Okay. So let your course rep see me tomorrow so that we can see what venue will be suitable for us. Now, that aside, this will be the last topic, my last topic with you. That's the prostaglandin. I've sent the YouTube link for people that will not so that will not be distracted in course of the lecture. So prostaglandins, can you see my screen, please? I'm sharing it already. Can we see the screen?
Yes, ma'am.
Yes, ma.
Can we see the screen? Please, I'd like us to Okay, sorry. Please, can we see? Sorry for the interruption. Can we see my screen? I'm sharing the.
Yes, you can see it, ma'am.
Yes, we can, ma.
Thank you. I'm sharing the topic for today. So our topic for today is prostaglandins. And prostaglandins are chemical messengers. They're chemical messengers that are produced at the at the point of action where they are needed. Okay? They are majorly produced from fatty acids. And we have the essential fatty acids and the non-essential fatty acids, just like we have in amino acids. Who can give me an example of a non-essential fatty acid? Okay, let's this be our first.
Palmitic acid, ma'am.
Palmitic. Okay, you saved the class. Palmitic acid. Okay. Now, there are 3 essential fatty acids. I want us to, in the next 2 minutes, I want us to send it to the group chat. Not group chat, to Zoom chat for this class. The 3 essential fatty acids. I want their scientific name. Don't just give me short form, the short name. I need the scientific name. Then in bracket, you now put the short name. Okay, I'd like us to do that within the next 2 minutes. The 3 essential fatty acids. While we're at that, please fill in your details in the attendance for today. Let's see, we have 3 charts. Let's see. Arachidonic acid. No, when I say in bracket, I need either omega-3, omega-6, omega, yes. Akoni is right, Rachel. Linoleic acid, omega-6, alpha linoleic, omega-3, arachidonic acid. You repeated it. There are 3 different types. Okay, omega-6, omega-9. There are 3. Omega-6, omega-3. There's one more you're leaving out. Let's see. Who else? Omega-6, omega-3. I hope you're not copying and pasting another person's answer. I'm just seeing the same response. Okay, just few people have responded. Okay. Omega-6, omega-3. Okay, so our time is up. Our time for that is up. The 3 essential fatty acids, even though the last one is not really termed essential, some texts term it essential, some texts don't, is omega-9, omega-3, omega-6, omega-9 in that order. That means omega-3 is the most essential fatty acid. Now, where is omega-3 fatty acid found? Where is omega-3 fatty acid found? In the chat box, let's see. Omega-3 fatty acid, where is it? They are found in fishes caught on the high sea. Yes, chia seeds. Thank you. Infinix Hot 50. Please change your username to your name and your matric so that the right response will be recorded for you. That Infinix, please change your username to your name and your matric number because this class is recorded. Fatty fishes. I'm knowing that for the first time. So these omega-3 fatty acids are found in fishes caught on the high seas, like our kote, shower, mackerel. Please note, they are not seen in fishes that are bred locally. They are seen in fishes caught on the high sea because these fishes feed on the zooplanktons and chordoids at the seabed, underneath the sea. That is where they get it from. And it's important to note that these prostaglandins, the prostaglandins are synthesized from fatty acids. Fatty acid is the raw material. The fatty acids on the cell membrane is the raw material for synthesis of prostaglandins. It's also important to note that these prostaglandins, they could be pro-inflammatory or anti-inflammatory. What do I mean? The ones synthesized from the non-essential fatty acids are pro-inflammatory. That means they trigger inflammation. while the prostaglandins synthesized from the essential fatty acids are anti-inflammatory. That means they reduce inflammation. So depending on the starting material available when prostaglandins are needed will determine the one that will be synthesized. It's also important to note that if the pro-inflammatory prostaglandins are synthesized, what do you think will happen to this biological system? They will trigger a lot of inflammations, and you have swelling, redness. What are the 5 signs of inflammation? Who can help us out? We have 5 signs of inflammation. They will actually trigger inflammation in the system and reduce wellness and health, and reduce health and wellness. So back to our flow diagram, they are synthesized from the membrane fats by activation of calcium or an injury. When calcium binds, we remember in last class, we said calcium was, what did we say calcium was? It works with enzyme. We called it a name, a cofactor. Do you remember? Calcium is a cofactor. It works with so many enzymes in the biological system. So when calcium binds to phospholipase A1, A2, it activates this enzyme, and this enzyme goes and releases arachidonic acid from the membrane surface. Now, this arachidonic acid, in series of reaction, produces cyclooxygenase. And these cyclooxygenase are in 2 forms. You have cyclooxygenase 1, cyclooxygenase 2. So cyclooxygenase in series of reactions produces prostaglandin H2. This PH2 is the universal starter molecule for production of either prostaglandins E2 or prostaglandins I2. Please note, depending on the need of the body, it's the PGH2 will either produce PGE2 or PGE12. And you can see the arrow pointing to the need: fever, pain, vasodilation. That will show you that these prostaglandins are pro-inflammatory. Fever, pain, those are the characteristics of inflammation. And then for PGI2, you have blood vessel protection, anti-clotting. That's the function of PGI2, anti-clotting and blood vessel protection. Why is anti-clotting important in our physiological makeup setup? Who can tell us why anti-clotting is important? Anybody? Why is anti-clotting agent important to humans especially, or to animals? Thank you, Eze. Eze sent the 5 signs of inflammation. Now, we want to know, why is it important that our blood doesn't clot? Why is it important for the blood to freely flow? To prevent blockage. Ojo Grace says to prevent blockage of the blood vessels. Great. Anti-clotting agents are important. They help prevent blood from clotting. Now, okay, because if the blood should clot, it can be deleterious. It could even lead to death if it's not quickly well handled. So thank you. So we have 5 different prostaglandins that can be produced from arachidonic acid. You have the PGE2, which induces fever, pain, and vasodilation. We have the PGI2, which is responsible for blood vessel protection. We have the thromboxane. TX stands for thromboxane A, which is platelet clotting, and then you have the prostaglandin F2 alpha, is responsible for uterine contractions. So there are 2 major types of COX. You have the cyclooxygenase. You have cyclooxygenase 1 and 2. Cyclooxygenase 1 is an enzyme that is constantly being used by the body, and so it's constantly running, while cyclooxygenase 2 is produced on demand, is switched on during inflammation, pain, fever, or swelling. And that's when it is used. But cyclooxygenase 1, the function is to protect the stomach lining, protect the kidney blood from clotting, and also improve platelet function. So you remember that when you don't eat, some of you, when you don't eat, your stomach starts to bite you. So this COX-1 functions in preserving the stomach lining so that the acid in the stomach will not digest the stomach wounds. Now, drugs that inhibit means block the function, prevents COX-1 from working. Drugs that inhibit COX-1 is aspirin and ibuprofen. That's why before the doctor prescribes a drug for you, we would have asked you, do you have peptic ulcer? If you say yes, they will never give you aspirin or ibuprofen, because those ones, they inhibit COX-1 from working, and when this happens, the stomach walls are okay. So we said we have COX-1 and COX-2. Now, that is how the prostaglandins are produced. Now, how do they work? The prostaglandins do not enter the cells. They work by attaching to the cell surface, to their receptors on the cell surface, the G protein coupled receptors. And when they do this, a chain of reaction is triggered. For PGE, if it's PGE that is released, PGE now goes and increases cyclic AMP. And when cyclic AMP is high in the blood, it induces relaxation or calcium or increase in calcium, which helps for contractions of the muscles, depending on the receptor. Depending on the receptor subtype that. If PG1 binds to its G protein cell surface, it raises cyclic AMP. Please take notes. Each of these prostaglandins, they work by binding to the cell surface and raises the cyclic AMP level. But it now depends on the prostaglandins that got bound, because each of them is responsible for their own specific physiological response or reaction. So if it's PGI1 prostacyclin that was activated, prostacyclin induces blood vessels relaxations, and so if it is prostacyclin that was induced, it allows for platelet relaxation and also the relaxation of the blood vessels. Now the other one is the thromboxane, and just like we've seen earlier, it allows the clumping of platelets, increases calcium, and then allows for the contraction of blood vessels. Please, it's important to note that the balance for prostacyclin and thromboxane is very crucial, because prostacyclin from vessel walls prevents blood clotting, while thromboxane promotes blood clots. And the function of aspirin, even at low doses, selectively blocks platelet thromboxanes. Aspirin is a blood thinner. That means it prevents blood clotting. And then that is how it works in protecting the heart. A blood thinner. So for people that have issues with blood clots here and there in different parts of their bodies, they are given aspirin so that it will thin out the blood and remove the clots. Okay. So this is a case study. Who will read it for us? I want somebody else to read so that I'll not be the only one speaking. Let me call Raphael Akoni. Are you there? How about Ojo Grace? Omolayo, is Ojo Grace there?
Yes, ma.
Okay, please
Good
read
evening, ma.
the case study for us. Good evening.
Ma?
The case study we have on the screen, please read it for us.
Okay, ma. So, a 65-year-old man takes daily low dose aspirin, 81 milligram, for heart protection. The science: platelets have no nucleus. They can't make new COX1 enzyme. One dose of aspirin permanently acetylates, that is, blocks their COS1 for the platelet lifetime of 10 days. Blood vessel endothelial cells can make new COX1 so they recover faster. Result: TXA proclotting is suppressed more than PG2 anticlotting, which overall gives net anticlotting effects.
Thank you. Do you understand what you read?
My,
Grace, do you understand what you read?
I think it's the science of what you said earlier.
Thank you. I don't want
The
to be sure. Yes, okay, continue. Let me let you learn. Sorry.
yeah, ma, that is the science of what you explained to us earlier, ma.
That was
The importance of clotting and anti-clotting.
okay. So which one is responsible for clotting? Prostacyclin or thromboxane?
Ma, it's trouble. Ma, is the trouble. This thing that is the TXA.
Is that our calling
There
for
is there is
thrombosis?
response. Ma, I'm sorry. That is responsible for
Please.
clotting.
We gotta use the right pronunciation so that in the exam it will not get stuck up there. So thromboxane is responsible. It promotes platelet clots. Thank you, Grace.
Thank you,
While
ma.
prostacyclin prevents clots. So this man, he has a medical history, a heart condition that requires him to use 81 milligrams of aspirin daily. And so we can see the science just to make us understand how this medication works. It works by suppressing prostacyclin, that is, and then thinning out the blood. Once you know aspirin, so aspirin works by inhibiting COX-1, that's cyclooxygenase 1. And once cyclooxygenase 1 is inhibited, it will prevent prostacyclin from being produced. And if prostacyclin is not produced, then the blood will not clot. So this is a case study in course or exam. I can ask it in a different way. I can say, what is the mechanism of action for aspirin? How does aspirin work? Is it the same answer? Do we understand? Just a minute. Just give me a minute. So, like I said initially, I could ask it in a different way in your in-course or in your exam, requesting for the mechanism of action of aspirin. And this is the same explanation, but with that, I'll also be seeing flow diagrams. So, and we said it's important to note that the function of COX-1's cyclooxygenase 1 is to protect this stomach lining. Please don't forget. So once COX-1 is inhibited, it will lead to ulcer, peptic ulcer. The stomach walls will be bleeding out because since COX-1 is not there to protect the stomach lining, the acid in the stomach will corrode the cell walls of the stomach. And that's what causes peptic ulcer. Is just wound in the stomach. It's just like when you injure yourself on your skin. It's the same thing in the stomach. So aspirin, even though it helps to thin out blood, is a drug that must be prescribed, must not be abused, so that you don't try to solve one problem and then now produce another one. So aspirin, even though is used in Nigeria like over-the-counter drug, it could be deleterious. It could be dangerous if handled wrongly. Even ordinary paracetamol too could have harmful effect. Paracetamol, if used abused, it damages the liver. So all these drugs, they say they are xenobiotics. As they are solving one problem, they are creating another. So you mustn't abuse the use of drugs. Now, we go to, okay, so we can see the problem with this 81-year-old man using aspirin. The problem is that since COX-1 is inhibited, he has peptic ulcer. Now, what is the solution? The solution will be to what? Even though he protects the heart, to prevent peptic ulcer, the doctors might switch to COX-2 selective inhibitors so that as the aspirin is thinning the blood, COX-2 will be inhibited instead of COX-1. Do we understand the logic there? If COX-2 is inhibited, it doesn't affect the stomach cell walls, okay? Or it will be given low doses of aspirin with misoprostol. And misoprostol helps in protecting the cell walls, the stomach cell walls. So that's so much for prostaglandins. Please, I'll advise us to jot, because most of what I said on prostaglandins are not in the lecture notes. So please, that's why it's important to take jottings. Now, the next one we'll be talking about is cyclic AMP, and I think we've spoken at that in the first class at length. If we remember, and we said some things that increase the function of cyclic AMP are caffeine, Viagra, milrinone. Increases when cyclic AMP is high, the level of cyclic AMP is high in the blood, it increases alertness and it increases the heart rate. Okay, I'll not go back on this. I'll not like to dwell much on this. The one we've not done so far was the prostaglandins. Now, the next thing I'll be going to is how they are linked, how the three are linked. But before that, let's talk about insulin. Yes, insulin is a hormone, is not a secondary messenger. Please take note. Insulin is a hormone, and the insulin gene on chromosome 11 makes pre-proinsulin, which is composed of 110 amino acid chains in 4 parts. So insulin is a hormone, is the first messenger. It's the first messenger that is triggered in the presence of glucose. Who can tell me the role of insulin? Okay, let's all send the role of insulin in the chat box. Let's see. What is the role of insulin? Insulin is triggered if glucose is present. So what do we think the function of insulin? I've mentioned it once before in this class. You just have 2 minutes to do that. I want to see how well we remember. Let's see what we have here. Okay, insulin lowers blood glucose. Thank you. So the function of insulin is to lower blood glucose, you are correct, by attaching itself to its receptor. When insulin binds to its receptor, it opens up the cell gates for the blood glucose to flow in, so that the glucose is converted to ATP. So that's the function of insulin. It's not a secondary messenger, it's a hormone. And it is triggered, it is produced in the presence when there is glucose. When you just finish eating now, the brain signals the pancreas, is produced in the beta cells of the pancreas. When one has just finished eating a carbohydrate-rich meal, the brain triggers the beta cells of the pancreas, which releases insulin that mops up the glucose in the blood. Okay. So this flowchart is trying to this flowchart is the explanation of I just gave is what we can see in these flowcharts. Once glucose enters the cells go to work through chains of reactions. ATP is produced, and the sensor for this to happen is the glucokinase. So let's check this case study. In this case study, who will read it first? Inyo, Temitayo, are you there? Isn't you there? How about David?
Yes, ma'am. Yeah, good evening, ma'am.
Good evening. Okay, please read this case study, the next case study for us to help us to understand what we just discussed.
Case study from pursuing insulin to Lispro, engineering for life. Scenario: a type 1 diabetic in 1980 versus 2025. 1980, she injects porcine, that's pig insulin, differs from human by one amino acid, B30, alanine instead of thyroxine. Works but can cause antibody reactions over time. Must inject 30 to 45 minutes before meals. Risk of hypoglycemia if meal is delayed. The problem: insulin naturally hexamerizes. After injection, it takes time to dissociate into monomers that can enter blood. Peak action is unpredictable. The engineering solution is insulin Lispro.
Okay, thank
Swap.
you.
Okay, yes, ma'am. You're welcome.
Yeah, so this case study is bringing to our knowledge that there has been vast improvements from the treatment for diabetics. People that cannot produce insulin often use insulin injections. They are advised to use it before meal. But in the 80s, this insulin was could have been extracted from pigs, and like you read to us, insulin hexamerizes. That is, after she injects herself, there could be what are those things they call when you react? There could be, is it what is the name of those reactions? When you react to a drug, what do they call it? What's the term that is often used? Is it anaplerotic reaction? But I'm sure you know what I'm trying to say. There could be side effects, yes. But now, and the only reason is because in pig insulin, alanine is the amino acid instead of threonine. That THR is threonine. So recently in 2025, B28 proline has been swapped so that the right amino acid is what is used to synthesize the insulin that is injected. So with lysine, instead of the dynamo interface is disrupted, and there will be no side reactions. There will be no side effects. So what happens is that injections to a mealtime is now 15 minutes, no more 30 minutes. And then peak action matches meal glucose spikes. So in summary, prostaglandins, cyclic AMP, and insulin they work hand in hand. Prostaglandins, they trigger injury, they trigger hormones. They increase or reduce cyclic AMP or calcium, depending on what the body adjustments needed is, and they are localized. Localized means the effect is localized, meaning where they are used, where they are produced. Where they are produced is where they are used. I remember when we were starting the class on prostaglandins, we said they are produced when needed. They are not stored. They are produced when needed. Okay, so if, let's take for example, you stepped on a pin and you really need to remove your leg from that spot, the prostaglandin that induces pain is what will be produced so that you remove your leg from the spot. Or if there's an invasion, fever, actually when you're running temperature and all that, is actually a good signal because your body is fighting antigens. So all those high temperature, what have you, it's actually your body fighting back by producing the pro-inflammatory prostaglandin that will fight the invading organism. So now cyclic AMP pathway, that's the glucagon and epinephrine, they activate pKa, which helps glucagon to break down. And glucagon is released in the absence of insulin, in the absence of glucose, sorry. Example, during starvation, during fasting, during intervals between meals, let's say between 8 and 12 hours, glucagon is released because the body is in constant metabolic state. The human body is in constant metabolic state, so it must use ATP. It needs ATP to the brain, especially the brain and the heart, they must never stop working. Otherwise, the person is gone. So those two organs are in constant demand of energy currency, which is why they cannot, there must be a means of energy supply in the blood cycle. Now, insulin also is a signaling hormone. It amplifies cyclic AMP and it signals the uptake of glucose. So the body doesn't waste energy. Every signal is tuned, amplified, and localized depending on the need of the body. Any questions or clarifications or modification? Any questions? Are we still here? Okay, so in the absence of questions.
Yes, ma'am.
Okay, thank you. In the absence of any question, I'll not trouble us with assignments, but I have some more case studies in the lecture notes, in the lecture material that you can go through while we read up for our in-course. We agreed on Monday. Today is Wednesday. Please, tell your course rep to see me, because whether or not you forget me, I'm going to be there on Monday. I'm going to be there on Monday, our normal lecture time by 2 at the venue for our in-course. So please, let your course rep see me tomorrow. Are you in school tomorrow? Are you usually in school tomorrow? Tomorrow is Thursday. Do you have anything in school tomorrow physically?
No, ma.
But you're in the
But we don't
but you're in
know
the
yet
hostel.
until the course rep.
Huh?
We don't know yet, ma, until the course rep drop the class for tomorrow.
Yeah.
We might not, ma.
Okay, whatever it is,
Yes, ma.
only him can come and see me. Only him should see me between tomorrow is Thursday. Yes, anytime from 2 in the afternoon. From 2, I should be in the office because I have a series of meetings in the morning. So between 1 and 2, you should come to my office in Akoka so that we can confirm. We need to confirm our class for next week, Mondays in course. And please inform everybody, because a lot of you keep saying, I didn't get the information. My phone spoiled. This one happened, that one happened. This is 5 days ahead of time. Our in-course for my part of this course is on Monday, 2 p.m. The venue will be communicated to us as soon as the course rep, as soon as we conclude, I conclude with the course rep. Okay, in the absence of any questions, please let all unmute and share the grace. May the grace
Of our
of
Lord
Lord Jesus Christ,
Jesus Christ,
the love of God,
the love of
the
God,
fellowship of the Holy Spirit,
and the sweet
be with us
fellowship of the
now
Holy Spirit rest and abide with us now.
and
Amen.
forever. Amen. Thank you. See you on Friday for 322. Okay.
Amen.
Bye.